is one that I keep getting questions on. It's about the mean value theorem. So if you want to keep working, just keep working. But if you're interested, just look up. So there will be between 1 and 3 questions on the test that will require you to remember the mean value theorem. There's some details of the theorem that won't be tested yet. The details are that the function we're talking about must be continuous and differentiable. Easy detail. The part that will be tested is you remembering that, okay, they gave me a function f, so I just always use my picture. It makes life easier not having to remember a lot of different graphs. And you've got to remember that for this curve f, that formula, like the slogan you need to remember is, for that formula, I plug in an x, I find a y. Or in some cases, I will plug in the y to find the x. Mean value theorem is talking about the fact that this point here is 0, comma something. But I can find the y coordinate just using that formula. So when I plug in a 0, I get a 0 here. This point is 2, comma something. When I plug in a 2 there, I also get a 0 here. You're okay with that, Jay? So the mean value theorem says I can use those points to calculate the secant slope from one end of the interval to the other. And that secant slope is always the change in y divided by the change in x. So in this problem, that would turn out to be 0 divided by 2, which is 0. Okay, there. So I'm rushing a little bit because of time. The mean value theorem says at least one, there could be more, at least one of the points along the curve, the tangent slope will have to be 0 because the tangent slope has to match the secant. So I take my formula for f, I use my pink derivative rules, and I create a formula for f prime. The slogan for this equation is plug in an x, find a slope, or plug in a slope to find an x. Well, I need the second version. I need to plug in the slope to find the x. Because I know I want this formula to somehow give me a slope of 0 at some x coordinate. So I just write that down. I want this to be 0. Well, finding the x that makes that 0, it's a little hard with that not being factored, so I'm going to factor. It's not a 3. Okay, to there. So now I can tell that if x equals 0, or x equals 4/3, if I were to plug either of those x's into this formula right here, the formula would tell me that at those x's, the slope of the curve is 0, which means those are the spots where the tangent slope will be the same as the secant. Cannot satisfy the mean value theorem at an endpoint, so that one doesn't count. That's why this is the correct answer. Good job, you guys. Good work.